So in this next lesson, we want to start talking about imaginary numbers. But before we get to imaginary numbers, I want to do something that reminds us of something related to imaginary numbers that's going to help us, but it's something that we've already been used to doing and we've been doing for several weeks now, and that is simplifying radicals. So I've got the square root of 16, square root of 32, and the square root of 108. And the goal is to simplify them. Now we know that the square root of 16 is simply 4, because 4 times 4 is 16. We're looking for a value that if we multiply by itself equals the value under the radical. Or, thinking about it in terms of pairs, 16 splits up into 4 times 4. I have a pair of 4s, so that comes out. That may be the method I use here because 32 is not a perfect square. I can break 32 up into, let's do 8 and 4. I can split 8 up into 4 and 2. I can split 4 up here into 2 and 2. And I believe I can split this 4 over here up into 2 and 2. I've got a bunch of 2's down at the bottom of each branch. I've got 5 2's down here. Now because it's a square root, I'm looking for pairs. So I see a pair here and a pair here. So if this pair has a 2 come out and this pair has a 2 come out, I have to multiply those together. 2 times 2 is 4. But then I still have this lone 2 right here left underneath the square root. So the square root of 32 simplifies to 4 root 2. Okay? And then this 108 is our last example. Let's start splitting that thing up. 108, I believe that is a 54 and 2. 54, I think I can cut that in half. I think that's a 27 and 2. 27, I can split that into a 9 and a 3. And this 9 I can split into a 3 and a 3. So I've got a bunch of 3's and several 2's at the bottom of the branches. Well, square root, let's look for pairs. I've got a pair of 2's and a pair of 3's and a lone 3 sitting right here. Well, a pair of 2's makes a 2 come out, a pair of 3's makes a 3 come out. 2 times 3 is 6, so it's a 6 that comes out, times the square root of that 3 that I have left under. So remember how to simplify radicals, because that's going to come up now as we look at imaginary numbers. So what is an imaginary number? Well, here's the question we have to ask ourselves. What happens when you have a negative under a square root? So here's the example. We've got the square root of negative 25. Now, if it was just the square root of 25, that wouldn't be too bad because we know that the square root of 25 is simply 5. Why? Because 5 times 5 is equal to 25. Here's the problem. You might say, though, the square root of negative 25 is just negative 5. Well, what is negative 5 times negative 5? It isn't negative 25, it's back to positive 25. Here's the problem. What number can I multiply by itself and it end up being a negative? And the answer is none, until we construct this new number called the imaginary number. So here's how the imaginary number works. We've constructed a way to be able to deal with this scenario. The way we've decided to deal with it is by adding another number to our number system called the imaginary number. The imaginary number is the context when you have negative 1 under a square root. So what we've done is we've labeled the square root of negative 1 as I. I is our imaginary number. Whenever you see I, it means that there's a square root of negative 1. In other words, a negative under a square root. So how am I going to tackle this over here? This is what I'm going to do. Very first thing I'm going to do is I'm going to realize that this negative 25 can be split up into a negative 1 times 25. Square root of negative 1 times the square root of 25. And you'll see that now I have square root of 25, which I know just equals 5. And I have the square root of -1, which over here we just defined as our imaginary number. So this becomes I. Now don't get too flustered about that, because all we've done is defined something. We haven't done anything mystical or magical. All we've done is defined the square root of -1 as I. It's our way of being able to deal with it and still do the radical, but my final simplified solution is going to be 5I. What that's going to communicate is, yes, it was the square root of 25 because it's simplified to 5, but it's 5I because it was a negative 25 under there, not a positive 25. So let's practice that a little bit more. I've got two more examples here. I've got the square root of -112. So the very first thing I'm going to do is I'm going to deal with the negative under the square root. And I know how to deal with that by taking and splitting this up into the square root of -1 times the square root of 112. And I know that the square root of 1 is I because we defined it that way. So I know that an I comes out of my radical. And now, since the 112 is positive, I can simplify it the way I'm used to simplifying it. So let's see, 112, let's cut that in half, and I get a 56 times a 2. I think 4 goes into 56. Yeah, 56 divided by 4, that's a 14. So yeah, 14 and a 4. The 14 splits into 7 times 2, and the 4 here splits up into 2 times 2. So let's go ahead and now look for pairs, because I think, yep, I've brought it all the way down to smallest terms. I can't split up anything else. So here's a pair of 2's, here's a pair of 2's, and I've got this 7 left over. So a 2 comes out and another 2 comes out. 2 times 2 is 4. So I've got a 4 that pops out, but don't forget, because I had a negative under there, I also had an I that came out to remind us that there was a negative under the square root. So 4 comes out and so does an I, and the 7 is left under the square root. So the square root of -112 simplifies to 4I root 7. And again, remember that I simply indicates that it's an imaginary number because we had the negative under the square root in the original problem up here. So one more time, we've got over here 4 times the square root of -44. Again, I see that I've got a negative under here. One way to think about it is this: if you've got a negative under your square root, you've got to pop an I out, and that deals with it. So thinking about it that way, I see a negative under the square root, which means an I pops out. So I could write this as 4I times the square root of, because I popped the I out, it's now positive 44. And now I can go to work on that positive 44. 44 splits up into 11 and 4, and the 4 splits up into 2 and 2. I've got a pair of 2's, so a 2 comes out. I've already got a 4 out here, so 4 times 2 is 8. So I have 8I on the outside times the square root of, I've got this 11 left underneath. So that simplifies to 8I times the square root of 11. So the last thing we want to do is we want to talk about what are called complex numbers. Now, a complex number has a real part and an imaginary part. The real part refers to the numbers that you're used to working with. They're all the numbers that you've been doing math with for the past several years. Well, really since kindergarten, when you first started doing math. It's all of the numbers that are integers, whole numbers, rational numbers, irrational numbers. All of the numbers that you're used to dealing with are real numbers. It's this new piece called the imaginary number that is now new to us. And what we have here with a complex number is a situation where we have the sum or the difference of a real part and an imaginary part. The imaginary part is obviously the piece that has the I on it, 2I refers to 2 times the square root of negative 1, because that's what we defined I as. So we have two numbers here as examples, 3 plus 2i, real part, imaginary part, and we have 4 minus 7i. The 4 is the real part, the negative 7i is the imaginary part. And what's nice is we can actually add complex numbers together. I cannot add the real part to the imaginary part. So I can't do the 4 minus 7 to get negative 3i. That doesn't work. Or over here, I can't do 3 plus 2 to get 5i. That doesn't work, because you cannot combine real numbers and imaginary numbers. So if any number has the imaginary part, the I, attached to it, it cannot be combined with any other real number through addition or subtraction. But what we can do is, if I've got two complex numbers that I'm adding together, I can add the real parts together and add the imaginary parts. So this becomes 3 plus 8, which is 11, and 6i plus negative 4i becomes positive 2i. So 3 plus 6i plus 8 minus 4i becomes 11 plus 2i. And then over here I can also find the difference of two complex numbers. So that is negative 2 minus 3 is negative 5. So that's the difference of the real parts. Negative 2 minus 3. Now I want to find the difference of the imaginary parts. Negative 4 minus negative 8. Careful, minus negative is actually a positive. So really this is negative 4i plus 8i, which gets me positive 4i. So that becomes negative 5 plus 4i.